Howdy, it's Mr. Russell, and let's talk about polyatomic ions. A polyatomic ion is an ion that has more than one atom. Here are some examples. There's nitrate, which is NO3 with a minus charge, and hydroxide, which is an OH with a minus charge. These will all have some kind of charge to them, and these are all covalently bonded molecules that are either heavy or lacking some electrons that make them have some kind of charge. When you see these, you need to really try to think of these as one whole group. NO3 is always nitrate, and we'll just refer to it as nitrate, not nitrogen trioxide. We'll just call it nitrate. And hydroxide is always going to be OH. The great thing about these polyatomic ions is you don't have to memorize them in first year chemistry. Just go to the back of this periodic table and you've got all your polyatomic ions listed for you. You have them in alphabetical order here in the name. The names are alphabetical order and the chemical formulas are right next to them. You also have the charges right next to them as well, so there's no need to memorize, just know where they are and know how to use them. So if I get an example or of a formula of a name that I need to find the formula for, I need to understand that lithium is Li. It's in group 1 in the periodic table, so it's a positive 1 charge. And then nitrate is, I refer back to my reference sheet here, and I look down for nitrate, and I see it's NO3 with the negative 1 charge. It's down here at the bottom right here. So that is NO3 negative, and the positive and negative will cancel out so that my answer or my chemical formula is going to be lithium nitrate, or LnNO3, LiNO3. Another example is copper sulfate, or copper 2 sulfate. You know of your study from the type 2 ionic compounds that since this is a Roman numeral of 2, its oxidation state is a 2 plus. And the sulfate is from your reference sheet, and that is all the way down at the bottom, SO4 with a 2 minus. So again, these will cancel out all nice and neat. The 2 plus and the 2 minus will now cancel out. There's no need for the crisscross rule because they will attract and to form copper CuSO4. Notice that these look very much like ionic compounds because that's what they are. They are ionic compounds that just have an extra flavor added in there, an extra covalent bond that is bonded right here. But since they're heavy 1 electron, they now have a negative charge and they attract to the positive charge. So that's how we get lithium nitrate. So now what would happen if I had the formula instead of the name? And I needed to find the name. So I know that Ca is calcium, and that is in group 2 on the periodic table, so that is going to be calcium as the 2 plus. And I know that hydroxide, OH, is here, so that is OH, but there are 2 of them. OH has a minus charge because I'm looking at the reference sheet, and there are 2 hydroxides. Fortunately, for an ionic compound, we don't need these two. We don't need to distinguish this. This will just be calcium hydroxide. Again, ionic compounds do not need to be. We don't have to distinguish between if it has 1 or 2 or more than 1. Here, we just need to know that it has the formula. I'll do another one a different way. We have KClO3. K is going to be potassium. And ClO3, I check my reference sheet, I look at it, and I see that it is chlorate. So that will easily be potassium chlorate. If I have NH4OH, so now we've got an interesting thing here. This NH4 is actually a polyatomic itself, a polyatomic ion itself. It is the only one that is a positive charge. All of the rest of them are negative. So this one is very popular on tests, where we have ammonium and then OH is going to be hydroxide. I'll work out the last one. This is going to be FeCrO4. Okay, so we have a transition metal, so that should raise a red flag that this is going to be a type 2 ionic compound. So let's go ahead and break down its charge. Fe is, I don't know its charge right away, do I? But I do know chromate's charge right away, because chromate's charge is going to be CrO4 with a 2 minus. And since there is one chromate for every one iron, I know that this negative 2 has to cancel out with this positive 2, or a 2 plus. Okay, so now I know that this is going to be iron 2 chromate. Thanks for watching.